This is a video from section 2.7. The directions say to find f prime of a at the given number a. Now f prime of a is the limit as h goes to 0 of f of a plus h minus f of a divided by h. So we're going to use this form of the definition. Now let's take a look at example 1. And we have f of x equals the square root of 4x plus 1. And a in this example is equal to 6. So f prime of 6 is the limit as h goes to 0 of f of 6 plus h minus f of 6 divided by h. And so this is the limit as h goes to 0 of. I'm going to replace x with 6 plus h. So I get the square root of 4 times the quantity 6 plus h plus 1. And I'm going to subtract the square root of 4 times 6 plus 1. And I'm going to divide the whole thing by h. And so this is the limit as h goes to 0 of. In the numerator, I'm going to distribute the 4 inside within the square root. And so we're going to get the square root of 24 plus 4h plus 1 minus 4 times 6 is 24. 24 plus 1 is 25. The square root of 25 is 5. So we're going to subtract 5 and divide by h. And so this is the limit as h goes to 0 of the square root of 4h plus 25 minus 5 divided by h. Now, the traditional way to handle a problem like this is we're going to multiply the numerator and denominator by the conjugate of the numerator. And so in this case, the conjugate of the numerator happens to be square root of 4h plus 25 plus 5. And so we're going to multiply numerator and denominator by that. So we get something like this. And notice how the stuff in blue is equivalent to 1. And so whenever you multiply by 1, you don't change anything about its value. Okay? Now, on the next page, this is the limit as h goes to 0 of. On top, we're going to do square root of 4h plus 25 times square root of 4h plus 25. And what we get is what's left in the radical, which is 4h plus 25. And then 5 times 5 is 25, and we don't want to forget the minus sign. So we're going to subtract 25. And we're going to divide by h times the square root of 4h plus 25 plus 5. Do not distribute that h in. You want to leave it in factored form. And so notice how the 25s go away. And we get the limit as h goes to 0 of 4h divided by h times the quantity square root of 4h plus 25 plus 5. And then I'm going to cancel the h's. And we get the limit as h goes to 0 of, in the numerator we get 4, in the denominator we get the square root of 4h plus 25 plus 5. And now I'm ready. I can plug 0 in for h directly. I could do this by direct substitution. And so I get 4 over the square root of 4 times 0 plus 25 plus 5. But 4 times 0 is 0. 0 plus 25 is 5. Square root of 25 is, 4 times 0 is 0. 0 plus 25 is 25. Square root of 25 is 5. And so this is equal to 4 over 5 plus 5. And so the answer to example 1 is 2/5 when you reduce that fraction. Let's take a look at example 2. In this example, f of x is 5x to the 4th, and a is negative 1. So f prime of negative 1 is the limit as h goes to 0 of. Now, we get f of negative 1 plus h minus f of negative 1 divided by h. And this is the limit as h goes to 0 of. We get 5 times the quantity, and we're going to replace x with negative 1 plus h and raise it to the 4th. And then we're going to subtract 5 times negative 1 to the 4th. And we're going to divide by h. And so this is the limit as h goes to 0 of. Now, negative 1 to the 4th is 1. 1 times 5 is 5. So we get 5 times negative 1 plus h to the 4th minus 5 divided by h. Now, I am not going to raise that to the 4th power. Absolutely not. What I'm going to do is I'm going to write it this way. So this is the limit as h goes to 0 of 5 times negative 1 plus h to the 4th. Here, in fact, let's factor out the 5 here. And then we get negative 1 plus h to the 4th minus 1. Now, the trick on this is, and by the way, we have a denominator of h. I could view that as a difference of squares. And remember that a squared minus b squared is a plus b times a minus b, right? And so what I like about that is I could write it this way. You get the limit as h goes to 0 of. We get 5 times negative 1 plus h to the 2nd plus 1 times negative 1 plus h to the 2nd minus 1. And we're dividing by h. So this is the limit as h goes to 0 of. Now, here you get 5 times negative 1 plus h to the 2nd plus 1. And what's nice is, if you look at that second factor, you could view that as a difference of squares as well, because 1 squared is the same as 1. And so I could write this as negative 1 plus h plus 1. Here, I'll put parentheses around the negative 1 plus h for emphasis. And then I'm going to multiply by negative 1 plus h minus 1. And then I'm dividing by h. So I did not want to raise that to the 4th power. It's too tempting to do that. I get it. But it is much easier if you can factor it. Because now look what happened. The negative ones cancel, right? And so what's beautiful is look at what you have left. It's the limit as h goes to 0 of. Now in the numerator, I have 5 times negative 1 plus h to the second plus 1. Notice how I didn't square out that negative 1 plus h. It's not necessary. And I'm going to multiply by h. And then I'm going to multiply by h minus 2. And I'm going to divide by h. Here's the cool part. These h's go away. And so this is the limit. Here, let's go back to this color here. This is the limit as h goes to 0 of. I'm going to take 5 times negative 1 plus h squared plus 1 times h minus 2. Now I'm ready to plug in 0 for h. And so this is 5 times negative 1 plus 0 to the second plus 1 times 0 minus 2. And so this is 5 times negative 1 to the second is 1. 1 plus 1 is 2 times negative 2. The answer here is negative 20. And that concludes this video for section 2.7. We did 2 examples using the limit definition. F prime of a is the limit as h goes to 0 of f of a plus h minus f of a over h, all over h, to find f prime of a. Okay, thank you.